Hello, everyone, and welcome. Thank you all for joining us for today's session. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, there are a few things I'd like to go over with. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary and remain professional and on topic. This session is recorded. It will be available on the through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link of our YouTube channel in the chat. I'll also be sharing some links like the Reactor Meetup page and the link for our survey so we get your feedback. I also want this, which brings us to our session today. This session will run for approximately an hour and a half for questions throughout. Our speaker for today is Armando Lacerda. He is an Azure Data Platform Architect and Engineer. I am now going to pass this along to you, Armando.
Thank you, Faraz. And good morning, good evening, everybody. Good afternoon from wherever we are connecting from. Welcome to our session today. And our session has a very interesting name, right? Very auspicious name. If I can get my slide here to flip, let's see. There we go. Predict rocket launch, rocket launch delays with machine learning. Well, as you can imagine, our session is actually about machine learning, and it's about how to use machine learning in Microsoft environments. And the use case we're going to be using here is from NASA. It's actually from NASA. It's about how to predict if we're going to have a successful launch based on weather data, based on the current weather data compared of what we have seen in the past. So welcome to this session. It's going to be super fun. My name is Armando Lacerda, and it's a pleasure to be here. Just a little bit about me. I'm a Microsoft MCT. I've been training Microsoft classes for over 26 years. I love doing classroom environment and teaching Microsoft data-related topics. I've been working with Microsoft data technology for that much long as well, and I've been doing data engineering lately and supporting teams on AI and machine learning, and have the data scientists with all the things they need in order to do their work and train machine learning models. I'm also a Microsoft MVP, which means I've been awarded by Microsoft with the MVP title. And Microsoft gives this title to professionals like you and me who like to go into public stages like this and share what they know about Microsoft tech and open source tech and cloud tech. We write blogs, we answer questions on public forums, we do sessions like that for user groups and conferences. So if you engage yourself in this kind of activity and you get noticed by Microsoft, you can also be awarded the MVP award. And it's a great honor to have that one. It's the one I cherish a lot. I also have a lot of Microsoft certifications. I've tried to get certified in every single tech that I care from Microsoft and other vendors. I hold dozens and dozens of them. And in case you want to get the conversation going after this session is over today, you can go ahead and connect with me on LinkedIn. I have a profile there on LinkedIn for the technical conversations. I usually publish stuff, either blogs of mine or articles or some news that I get from the social media, from Microsoft feed. I don't tweet much. My Twitter feed is usually an echo of what happens on LinkedIn, but if you want to connect there. And Facebook's more for personal things. I think you're going to drop this Facebook icon here someday, because there's no technical content in there. It's just me riding my motorcycle around here in California. All right, so let's go into our content. Let's go straight into our content. We have a very packed hour ahead of us. And it's so packed that I have only two topics. We're going to have an intro to ML, and we're going to have a workshop. We're going to see how to get this thing going, how to work with this. So that's just my two topics for the session. But actually, I have two goals here in this session. And if you have been in these sessions lately, I have delivered a few sessions last week and the week before. This session is part of a series of building skills. We want you to be able to develop your skills using Microsoft resources. And the news about that is that Microsoft still runs Microsoft classes. You can go and attend a class. And if when you attend a class, you're going to have an instructor there. And the main element of a class is the actual instructor, right? We used to get books or, this courseware that they give around. You get that reference material. Used to be print out, and lately became, for the past 10 years, it became digital. You can go to SkillPipe and see the things there if you attend an official class. But again, the main thing about being a classroom is your interaction with the trainer. Well, Microsoft understands that, and they still offer the official training for all of the things you're going to see here. But they decide, look at this, they decide to make all their content, the actual training content, available for free on Microsoft Learn, on this logo here on top of my head, on Microsoft Learn. So if you pop up your browser and you go to Microsoft Learn, you will get access to hundreds of learning paths for a lot of Microsoft technologies. I think pretty much all of the Azure ones, the cloud ones, and you can start learning about the tech you want to learn. So this workshop here will be about a particular learning path that's there. We're going to have it here on the screen for us in a second. Is about a particular learning path they have there on machine learning about this use case of predicting if a rocket launch will be delayed based on weather data, which is very interesting. So my goal here is twofold, right? One is to give you get your feet wet on machine learning. And the other one is to show you how you can go ahead and have your own hands-on after this session. So a bit demoing whatever is there in the learning path. And my hope is that you will see how you can do that yourself later, so you can experience on your own computer how you can do machine learning development. So let's go ahead and tackle these topics. So the first topic here about machine learning is understanding what's the actual process. When we talk about machine learning, for the most part, we are talking about statistics and statistical models. So we're gonna hear this jargon, this term around called model. We got an AI model, we got an ML model. That model is actually a statistical model. And the idea about statistics is if you look into data, you can find patterns. And if you look at these patterns, you can have some calculation on probabilities of a particular element you want to predict. And that's the whole idea. The idea of AI is imitate how the brain thinks and how we use our brain, how the brain works, and have the computer working on the same pattern and the same kind of imitating how our brain functions. It's a very auspicious goal, and there are a lot of researchers going on that one. For the things we're going to do in here, we're going to restrict that to specific calculations, right? The models and predictions based on statistical probability. There are a lot of elements about that, but on the specific topic we are in hand here, there are two ways we can use these models. One way is like I can subscribe, I can sign up to models that other people have already trained, and they know how to work on particular subject areas, or I can create my own. I can get a model that is crude, there is it's just the calculations, and teach that model how to look into the data for my own particular use case. So I have two ways to go, right? I can get a one that's been already trained, or one that I will start training from scratch. In Microsoft Tech, the one that's already trained, and if you want to use that from the cloud, is called Azure Cognitive Services. So if you want to make a note in there to search for it later, go to Microsoft Learn and look into cognitive service. There are a bunch of content in there. You can see cognitive service there. So like if you want to do vision, and if I want to show, if I put here a picture of a celebrity and I want to identify which celebrity is that one, the cognitive service can do that with the vision service. Same thing for text recognition and voice recognition. There are a bunch of other things you can do in there. They're already trained, ready to use. You can embed that in your application, and your application is good to go with embedded AI from Microsoft. And you pay for the use because they have already trained that. What we're going to do here is different. What we're going to do here is we're going to get those statistical models and have them working for a use case that's pretty unique. And that's the case for a lot of a business out there. Some elements are very familiar. Taking a picture and recognizing what's in the picture is something that we usually do for regular objects, not very specific objects. So you can use pre-trained models. But when you work on a context like this, rocket launch, then you have to create your own models. You have to train your own models based on the data you're working with. And that's the case for multiple other elements in there. There are many use cases on the Microsoft website. If you look there for the use cases, there is one that got my attention from a few years ago when they used to have helicopters flying over power lines to see if there is any damage on the power line and needs repair. And sometimes they send crew there in trucks, just to inspect the thing to see if there is anything that needs to be fixed. And then what is pretty big logistic, right? Get a helicopter, get a truck. They start doing that with drones, with embedded AI in the drones. So the drones look at the power tower and see if there is anything that needs to be fixed in the power tower. And it's a very interesting use case, very peculiar. They need to have a machine learning model trained for their particular one, but save them a lot of money over time, right? Because they now can have they can fly something that's very inexpensive compared to a helicopter or driving a truck in the wilderness. So that's what we are talking about here. It's about creating a model that's specific for my environment. When we do this, this is usually a task for developers. Creating behavior, when you want the computer to do some behavior for you, it's something that developers used to do. And they still do, of course. But it's something about development. What we do in machine learning is defining calculated elements, calculated behavior based on mathematical formulas. So it doesn't require a developer, even though we're going to do coding here. And what it does require, though, are two types of people. One is a subject matter expert. Someone that's not a computer guy per se, is someone that understands the business and the elements we're talking about, like in case of the power line, what to look for, what should be in the image that would tell me that it needs a repair, right? In the rocket in here, the rocket launch case, what are the weather conditions to look for that would tell me that I'll have to delay the rocket launch? And so therefore, you need a subject matter expert. The other one you need is a data scientist. It's someone that can work with the data, can prepare the data that we're going to use to train the statistical model, and with in partnership with the subject matter expert, start defining the meaning of that data and define patterns for cleaning up the data and things like that. So the data scientist will work in some environments that will allow this data manipulation. Now, in this particular case, there is a a split in between a data engineer and a data scientist, right? And while the data engineer would get the data from your sources to handle over to the data scientist, and in doing that, there will be some data cleansing going on. The data scientist will do the second half of that data cleansing, right? Which is applying specific data values to the elements that came up from the data engineering. So it's a big effort. That's why when you create a machine learning model from scratch, it takes a little time. Depending on the subject area, it may take months, and it will take a team, right? It will take a team with multiple people in there from specific aspects. Because at the end of the day, what you want is a machine learned model that you have trained, that you want to put in production, that will look into data come in from production environment, whatever your production environment is, and try to make predictions. The whole idea flows in 4 steps, and this will work like a review of the things I have just explained. So the life cycle of data science to create a machine learning model is based on this, right? We define the business goal, what do I want to do, and we use as me, right, the subject matter expert on that business area to define this business goal. But again, when you say business goal, be very careful, because you can really, when you define business goals, you can be somewhat subjective. Like, what's my business goal? I want to launch the rocket. Okay, that's a business goal. What's my business goal? I want to keep the power line working. That's a business goal. And there's some many other ones in there. But when it comes to machine learning, you have to be very specific on what kind of prediction you want to achieve to get to your business goal. So in this case here, there will be a lot of information about weather, and the subject matter expert is not here. I'm gonna change hats here as we do this. So the subject matter expert has already seen the data and said this is the data we're going to be working with, and the goal is to predict, is the launch going to be delayed? So this is a very specific business goal, right? Is the launch of that rocket going to be delayed? Yes or no? In this case, it's a yes or no thing. It could be a range of value, like look into a car and how much that car worth. So we can do that based on pictures. You can do that based on description of the car and all the elements about the car. And then you can define, how evaluate how much. So there's another kind of prediction or evaluation. There are multiple types, right? And the data you use to analyze the business element for your business goal is usually called features. Features are like columns for a table. If you're familiar with databases or Excel spreadsheets, have columns there on the table. Features kind of the same thing, right? It's columns for a table. But one of these columns is what you're trying to predict. And that in the data science field, that's called a label. So we have the features, which is the data that you're going to use to analyze, and you have the label, which is what you're trying to predict. And your business goal is usually related to the label. It was what you're trying to predict, what you're trying to achieve. You have to have that written on stone, and it's always one label and one label only. So like when you have a picture and you give that picture to the computer, say, what is in this picture here? That's a business goal. What is in this picture in here? But could be many things, which means that I have multiple models working on the same picture, trying to identify what each one of them is designed to identify. So if I have a dog, a cat, and a fish on the same picture, there will be multiple models to identify each one of these animals if they show up on a picture, right? So a particular model is designed to answer one question and one question only, to work on a label and one label only, right? That's very important. That's how you start, where I want to get to. The next thing you do is you start collecting, this one, data-driven. You start collecting, cleaning, and manipulating the data you're going to use to train your model. Remember, there are multiple ways. And the next slide here, two slides ahead, we're going to have a cheat sheet here on the models we can use for multiple occasions or multiple business cases we want to apply AI to. But if the model is unsupervised, you don't have this step here. If the model is unsupervised, you just flow the data and the model try to adapt to that data there. That's another subject. If you were here yesterday, we had a session like that yesterday on another subject. You saw me talking about that, about unsupervised models. If you're not here, go back to our YouTube channel and check that session out. But in this case here, we're talking about supervised models, which means I have data to train the model. The model needs data to be trained. And when we do that, we get that data. We look into the data to see if there is any consistency on the data in terms of missing data, repeated data, data that needs to be converted into scales and things like that. So we do that. In doing that, we do also manipulation. So this kind of the same thing on these two here, right? Two faces of the same coin. And then we get our data. With the data, and we're gonna do this in this workshop. The workshop itself, the instructions that we're gonna go over, will do this task. So you're gonna have hands-on doing this if you decide to go and try the workshop yourself. The next thing is it's in one line here. It's trying to make it 4 steps only, right? 4 steps. But this one here, as you can see, that has multiple parts to it. So the first part is you're going to choose which machine learning model or algorithm, right? Which machine learning model or algorithm you want to use for your particular case. This is a very critical step, right? Because the model you're going to use will define the accuracy and how reliable your machine learning model will be. So testing multiple algorithms, multiple statistical models with the same training data and compare results is something that the data scientist does. There are ways to automate this nowadays. It's usually under an umbrella name of AutoML. So we give the training data, you define which kind of prediction you want to do, and we'll run multiple possible models of that particular type, like a regression model, for instance. Run multiple regression models on that data and see which one adapts better to the data you're working with. So you choosing the data, choose the machine learning model, right? The statistical model or the learning algorithm to apply to your case is the heart of the thing, alongside with getting the right data. And when you choose, you mix these two guys together, your statistical model with the data you have prepared, and you train and test. This is where you're going to make your decision as you train and test. This is where you're going to make your decision if your model is trained enough, you have enough training data, or there is another model that's better than the one you are training right now. There are multiple. There is a service you're not going to see here in this session called Azure Machine Learning, which is a service in Azure that can help you while doing this and speed up the process of doing this. Here, we're going to do more kind of an open source approach to this, which is using a Python language with Jupyter notebooks and some public libraries that are out there, and you're going to do this training by hand. So once you have done this, you're done, right? You got your model created. You're happy with the predictions of your model, and you're ready to send this model over to be placed in production. So you can, when the rocket is there in the launching pad, we can say, should we wait? Should we not wait? Should we delay? Should we not delay? Is this going to be delayed? Should I prepare things to support the delay of that launch? So you deploy your model. And once the model is deployed, your work as a data scientist preparing machine learning model is kind of done. But what happens is over time, that model needs to be retrained with new data. So the cycle kind of goes over here again. But these are the 4 steps, with the third one kind of being 2. These are the 4 steps of a data science life cycle. In the workshop, you're going to see in a few minutes, you're going to do all of them, right? We're probably not going to have time to do all of them here during this session, but I'm hoping it will be motivating you to go to your computer and try that out. And then we'll do all of them. This particular diagram here illustrates those 4 steps, right? We start by, and just to make it easier for you guys to read, let me pop this bigger here. So there we go, right over there. I think this clicker here should be working. Let me go back here. There we go. So we get the understanding of the business goals and the use case you want to deal with. And we start doing what we just explained, right? On this corner here, right? We come to decide which model to use. We do feature engineering. Remember I told you features like the columns of a table, right? So we look into the data that we have collected from the sources and see if that data needs to be massaged in a way that will not distort the results, but will help the statistical model to understand the actual data and do the model training and model evaluation. On the other side, right, on data acquisition, you always look into the data sources. This is kind of the data engineer side of it, the pipeline that's bring the data in, if the data needs some cleansing. And the data engineer and the data scientist, they're working together. Sometimes they're even the same person, depending on the size of the project. And once the model is evaluated and people are happy with it, you go into the deployment, right? You deploy your model, and that life cycle, that stretch is done. But again, from the end, it goes back to the beginning. Usually you want to retrain the model to get the model smarter and smarter as new data comes in that will help the model to make better decisions, right? If you have any questions about these things as I go, there's a lot of content here, a lot of concepts going on. If you have any questions about any of this, you are welcome to go and put there on a YouTube chat there. It will pop up here on my end here. And for us, it's monitoring the chat too. And he can pop up the question here on the screen in case you need any clarification, all right? This last one here, this last slide, is also on the workshop instructions that we're going to switch there after this. Is also on the workshop instruction. And what we see here, it's like it says, right? It's a machine learning algorithm cheat sheet. The whole idea here is try to help you out make decisions on which model to use on a particular case. So is the model still here? Yes, the model is still here. If I zoom in here just quick, like if I go to this corner, if what I want to do is text analytics, these are some of the models I can use for text analysis, like mood analysis, intention analysis, and things like that. It's very commonly used on bot automations when you speak with the computer trying to get what you need. Very common to see it over there. With the Microsoft environment in Azure Machine Learning in the cloud, you do have these things there available for you. You can pick one and start training on your own data. When we do open source, like you're going to do here now with Python and a bunch of other libraries there, like Panda and so on. A question here. Hi, how would we gain access to these slides PowerPoint? It's a not related question to the topic, but it's a great question. And these slides will not be made available, right? Because I just made this slide based on the content that's already there on Microsoft Learn. So everything I'm showing here is already there. So you really don't need the slide deck. I will show you where you're gonna find it in a second, right? And you're gonna have these images here with a lot of more content in there. So thank you for the question. That was a good one. All right. So another case you want to address is like regression case, right? When you want to do when you want to predict values. So regression is a good kind of algorithm for this particular task, right? You want to predict values. As you can see here, there are multiple algorithms you can try on your data, right? On your training data to see which one is able to do a better work in terms of predicting the results, right? In calculating the label. This is the thing that takes a lot of time, especially in this case here, because you have so many options in there. Then is when you want to look into something called AutoML that would help you to choose which particular one is better suited for your case. If you have some statistical background, if you know statistics, have some statistical knowledge, that will help you a lot. But in order to get this working, you really don't need to be someone with a statistical degree for that matter. All right, and there are many others in here. Like I said, you're gonna see all of that in your material from Microsoft in Microsoft Learn. So that was one question. See, there are other questions in here. Before I switch to the actual workshop, let's take a look on the next one. If you're interested, okay, so this is Microsoft Reactor. It's just my friend Ferris give you information, right, on this content. Perfect. So let me go ahead and switch to my browser. Let me see here where I left the browser open. It's here somewhere. There you go. Here's the browser. And this is right, this is the learning path for our particular content here today. Predict rocket. How do I get to this, Armando? Well, one way is writing this URL here. I wish I could put that for you on the chat window, but I can't. Or else can, but I can't. Another way you can do that, let me see here. Oh, there we go. He already did it. You see how efficient our team is? Predict launch delays, 0607 learn. We have aka.ms link for that, which is a shortcut, which is great. So if you click on that one, you will land on this page in here. I will not stop and read this for you, right? I'm gonna guide you on how to get ready, how you can do, and demo you how these things work. You should prepare yourself, give yourself time to go and read this content as we move along, because it's important for your learning experience. I'm gonna go ahead and make this a little bigger so you can follow along on that one. And when we get into Visual Studio, I will also get that bigger there as well. One note here for you is multiple of these learning paths. And what are the learning paths again? Well, if I browse here to microsoft.com/learn, you will see here, there we go, you will see here multiple learning paths. You see, so Python for beginners is one session I gave the other day, and it's tracking me. So if you log in to this, if you create a Outlook account or Hotmail account and you log into this, it gives you these points and you start collecting these badges, which is super cool. You can show people like, I've studied this. I'm investing time studying this. It's not like any certification, not getting certified, but it shows that you have invested time and went through these modules to learn about these elements. So there are multiple learning paths in here. Let's see this one here. Choose the right Azure service by examining SLA and service lifecycle. That sounds an interesting one. If I'm kind of a cloud engineer solution, I may want to take a look on this content here. There are multiple of these learning paths available for you. Some of these learning paths will give you a sandbox. Like as you move along the learning path and you learn the topics, there will be always some hands-on for you to do. And some of these learning paths will give you a sandbox where you can try code, where you can do things. When it's Azure, for instance, sometimes they create an Azure subscription on the spot there for you. So you have a sandbox in Azure where you can try some tasks without breaking anything. It's super good if you get to find one particular learning path in here for that. You're great. You're in a good environment. On our particular case, for this learning path here, there is no sandbox in the cloud for you to do this, right? You will have to set up a computer and install some software on a computer to try this out. And it's kind of fun because you get to touch things on what's in there in the public environment, in the open source environment to collect that. But it can consume some time. So don't be frustrated. I'm going to show you how that works. Don't be frustrated if it consumes you some time. I was talking to Faraz before this session here. I was preparing a virtual machine for this one, and it actually took like an hour and a half to get the thing installed, something hanged up on that virtual machine. On this computer here, it kind of ran a little faster. The point is, you will have to install some stuff on your computer, right? So let's go ahead and see how this particular learning path works. So there's always this start button here. You see the rest of the content showing up down here as you browse down. And you always follow the buttons, the start, the next, and it should be fine. Just in case I close my tab by mistake, I'm going to do control click on this start button here, and it will open a new tab for me up here. And from this tab, we'll move on. All right, so here again, this is a case based on a NASA need, which is, check the weather, see if we have to delay or not the launch of a rocket, which is super cool. Actually, I just been there with a brother from another mother the other day, 3 weeks ago. I was there visiting the NASA Space Center down there in Cape Canaveral. So always interesting case in here. So we got the text in here, some learning objectives, and then our continue button. Let's go ahead and move on here. I see something popping up. Let me see. Splinter cell, chaos theory. There we go. Yeah, something you can find there. Moving on. So this is the case. Remember, the first thing is understand your business case and what you're trying to do to accomplish that goal. In this case here, they're telling you in this text they're going to use data from NOAA. They're going to use data from NOAA. I think it's just NOAA. Yes, from NOAA. I thought it was another one. And they have collected that data into an Excel spreadsheet. So at some point there will be here they're telling you here, if you want to really get this data from the actual sources, just follow these APIs here. If you're a developer, you can collect straight from them. For this learning path, they kind of water down a little bit and get the data kind of the data engineer portion of this is already done and handled to us in the form of an Excel spreadsheet. So let's keep moving. There we go. Yeah, I got some satellite imagery, remote sensors, NOAA weather, got some data from some sources in there. Let's see what else is in here, what you can learn from the clouds, some text about that one. I still don't see the link. Yeah, we can go ahead and move on. Again, I'm skipping through this just to save time, right, for the sake of time. But when you do this on your own, I highly recommend you reading these things because it will give you into the context of the subject in hand, right? Because if you want to really apply machine learning, you have to understand the subject with some depth. We are not this me of that subject, but you have to understand it with some depth. So reading this one here is going to be important for you. Once again, see, for who was the person there? For my friend Pratik, who is watching online, who asked me about the slide deck. See, this is the picture that I had on my slide deck on the life cycle. These are the 4 steps that were there too. So you can come and you see it's available there for you for free, right? You really don't need this slide deck, like I mentioned. Set the goal of the expertise. So you talk to the experts on the area. They're not compute people, right? They're not data scientists or computer engineers or anything like that, but they do understand what it takes to get a rocket up in space. So you talk to these guys to see what's actually needed for your calculation to achieve your goal. And then we are on that step. Remember, on collect, clean, and manipulate data. This is the step we're gonna start have hands-on with the data. At this point here, they're still talking about the mindset, which is the presentation I have just done. And then it goes into the choosing the algorithm. Here's the cheat sheet that I mentioned before that you guys can use for making the educated decision on which model to use on a particular case. So it's also there for you. And I think, let me see. Yeah. So once you're done getting your data ready, train your model, you're going to deploy your machine learned model. And this is a very short paragraph here. It's just like, okay, you're done. Send it over to your IT people so they can get that done. All right, some extra text in here, something about visual recognition. You can take a look at that later. This is a topic I have not mentioned before, ethics in data science. remember what I mentioned earlier when they say that data science and machine learning is about imitating how the human brain makes decisions. So we can, the goal is to scale out the human brain, right? If I need two people to calculate a work, like one Einstein to calculate the work, that's great. But if I can have 1,000 Einsteins calculating a particular, doing calculations on a particular subject, I just scaled my decision make capacity. That's the idea on machine learning. You can do, you don't have to have 1,000 people in a room look at images to point out what's in the image. You can send an image to a machine learning model and try to let it do that for you at scale. The problem when you do that is if the model is not well trained, or if the model has some bias to it because it was trained based on biased data, you can do bad, right? You can do bad by other people. So every time we use machine learning, and this is a topic that is kind of a sidebar here for me in this session, but it's very core when you do machine learning, you should always make sure that whatever data we're using, you are not excluding people for any sort of prejudice, right? And they go over some elements in here, like, by race, by color, by gender, and some other stuff, right? Some other parameters. The bottom line is machine learning is about making decisions on other people's lives, on when they, like, if you are a bank and you are going to decide if a loan should be approved or not. That can be automated by a machine learning model, and if the thing is biased, it can be excluding people from a credit line that could be beneficial for the whole society. So make sure you understand, right? You take in consideration the kind of data you're working with. In this particular data, because just about weather, we don't have this particular topic being applied. If you look into yesterday's session, that is probably on the YouTube channel already, you're going to see some discussion about that, about gender and marital status. So I will refer to that one. At the end of these modules, they always have this knowledge check. And the knowledge checking here is going to be good for you to make sure that you got the principles and the basic ideas. Again, this is not certification level questions. It's just for you to, see if you grasped it. In this case here, which statement best describes the role of ethics? Be sure that the inputs are accurate because often output is used to make policy decisions. Yeah, this one seems to be the right one, right? The other ones are kind of sketchy. So the idea here when you do this one is reading through the question, make your decision here, make your choice, and at the end it will evaluate your questions, right, and your answers, and it will tell you if you did good or not. So in this case here, just gonna move forward and get to the next one because I have already completed that one. So let's go ahead and jump to the next one with data collection and manipulation. Here's where our hands will be busy. Notice here at the top, well, not there yet. Let's click here on continue. Notice here at the top that they have these units because I've been through this one already. It got me down all the way down there to the end of this one. So let me go to the beginning so you can see what is in here. Again, an introduction about what we're doing now with more hands-on elements. These are some of the data we'll be analyzing, which is super cool. Prerequisites, very important. What do you need to have on your computer in order for you to be successful, have the hands-on experience in here? They have this link here about Visual Studio Code and the Python installed. I believe on the next section 2, there we go. Let me see. Actually, no, let me go back in here. Let me control click on this guy, see what is in here. Yeah, so this is just the page to download the elements, and there is a video here about how to download that. So let me show you. There are some instructions about what you need to do here on the sequence of the steps. Where is it? Additional challenge, Unit Explorer. rocket launch data, collect data. There we go. So there are some instructions in here on a video that will pop up here somewhere about what you should have installed on your computer. The first thing you got to install, I mean, it can be in any order. It can be either Python first or this one first. But the first thing is Visual Studio Code download. So if you just search right for Visual, if you can type it, I can't. If you can type it, Visual Studio Code. Let's try that again. This guy. You will get to a link, download Visual Studio Code for any environment, which is great, right? Because you can use Visual Studio Code in any of these environments there. Important here, the important element in here is you can use any code editor for that matter, right? The learning path is a Microsoft learning path, so you're going to use Microsoft tools. They're going to suggest you to use Microsoft tools, but you can use any tool, right? As long as you can integrate with the underlying environment. The next thing you're going to need is Python. It's Python. Yeah, not a book. The software. This guy. Go download Python. What is Python? Python is a programming language, and it's a very popular programming language. And one of the things that's great about Python is once you learn that language, you can program in this language in multiple places. You can define behavior, not just for machine learning, like we're about to doing here, but you can define behavior for a bunch of other environments. Just to give you an idea, Microsoft has this service called Microsoft Azure. It's the Microsoft Cloud Service. And in Microsoft Azure, cloud administrators, they go in there and they get things going, like they have a database going, a web application going, they have machine learning going, they have a lot of things going on over there. And one of the things that a cloud engineer would do is creating scripts to create elements in the cloud. Like I need a database, so instead of creating by clicks, I should automate that by writing scripts to do that. One of their options there is Python. You can use PowerShell, you can use CLI, but one of the options you have is Python. Because even Microsoft engineers back in Redmond, they do that when they implement things for the CLI, for instance. So Python is a programming language that it's widely used in multiple environments, Windows, Linux, Mac, it's all over the place. So learning Python, it's a very good investment. I highly recommend it to you. And don't be, don't be intimidated by it being a programming language. Like I'm not a developer, I don't want to learn how to program. Yeah, you're not a developer, great. So you're not going to learn how to program, how to create a web application. But anything in a computer, you're going to write some code some way or the other. So Python is an excellent environment to do that. That's why we do it here in the machine learning environment, right? In AI for that matter, Python is one of the most popular, if not the most popular language, where you're going to find multiple machine learning libraries available for you. So there we go. You have to have Python installed. I have already installed this. Installing these two is kind of a quick. The third thing they're going to ask you to install on your computer in order to get through all of the exercises of this learning path is Anaconda. This guy here, Anaconda. There we go. So what is Anaconda? Oh, see, data science. So what's Anaconda all about? So when we need some calculation done on a higher volume of data, usually you dispatch that to a compute resource that will do that calculation for you. Anaconda is one of the options to have a backend doing that calculation of the training of the machine learning model for you. It's widely used, super popular. Is one of the options we have. We don't have to use this. There are other options out there. For this particular learning path, they would recommend you to use this one. Hope I can have time to get to demonstrate that as well. Installing Anaconda can take a little while. Right? That's one of the things that took a little while to install my computer. So if it feels like it's frozen, it's not moving on, don't feel like it's moving on. It writes a lot of things on the hard drive. So if you have a slower hard drive, it may take a little while to get it done over there. I already have all of these things installed in here, so I'm just gonna move on this, okay? But these are the prerequisites for you to install these elements, for you to do the hands-on for this session on the learning path. All right, so let me close this one here, and close this other one here, and close this other one here. Back to the learning path. There we go. So here in the learning path, they will say you need data to train your model. Remember, the first thing is understanding the subject and the question you want to answer. We have that down. It's written there in the text. I've kind of explained already. The next thing is, all right, so let's get the data. Was there a question in there? I think a question popped up in there. I will go back to the chat in a second. So the next step is now that I understand the goal, right? What I'm about to calculate, I'm gonna go ahead and collect the data and start working with the data that's available for me to make my prediction, right? To train my model to make the prediction. So like I said, these are the sources they use for that. And the data engineer that was borrowed to us by Microsoft put that data together and kind of synthesize that data, in a way that makes it easier for us to work here in this learning path and place that data in this Excel file. So one of the things you're going to do in here is you're going to get this Excel file here. I'm going to control click on the guy to open a new spreadsheet in here, right? A new tab, and you're going to download this file to your local computer. I have already downloaded to a folder on my computer. So if I switch here to Visual Studio Code, which is here, if I switch here to Visual Studio Code, you see here that I have in Visual Studio Code a folder called Reactor, right? Where I create a folder just for this demo here. And that spreadsheet, I have already downloaded it over here. This is the file on my spreadsheet. This is the file on my folder, right? The spreadsheet on my folder. So it's already there for me. If you're not very familiar, if you don't have much knowledge and not very skilled on Visual Studio Code, it's super easy to use. There's these blades over here on the left side. I may have some, I do have extra ones in here from some extensions I have already installed. So if you click in here, you see what you collapse and uncollapse these blades. So now I'm looking into the folder explorer, and I'm looking to a particular folder that I had opened, and I can create my files here. You're going to see that going on. There's integration with Git. There are extensions you can install. In our case here, if you follow along the learning path, they will ask you to install particular extensions. One is the machine learning, the Azure, this one here, the Azure machine learning, that I thought was already installed in my environment, but apparently is not. So this one is version 0.12, and this one is version 0.10. So more likely I want the latest one. And there is another one here, 0.1. Oh, there's a bunch. But yeah, so you choose this is a pre-release. This is not ready yet. You see, it's saying here on the side, pre-release, right? They're kind of testing that yet. They're inviting people to test with them so they can have some telemetry and make it better before it really launches. I do have it in here someplace already installed, but it's fine. The point is, you need to install some elements in here, some extensions. One of them also is the Python extension. That one is already installed, so the integration with the Python language is there for me. And something that's very popular among data scientists is the Jupyter Notebook support. And this one is published by Microsoft. So installing this guy, it's one of the things they're going to ask you to do, just to have a better support in the code editor and the environment within the code editor, integrated with the code editor in your workstation. So this creates the environment that we need. We should be good to go. Again, I just browse it with you here because it will take a little while to do this at this session. So we'll try to save some time for us in here. Let's see, I see some activity here in the chat window. Try to learn Python right now. What sources do you recommend? Well, you can use, there are great books out there, of course. I'm from the time when the internet was not around. So every time I think about learning something new, I look for a book. But nowadays, there are a lot of free resources out there. One that I do recommend, like you just asked, is, like I said, the Microsoft Learning Path. So if you go here into Learning Path, Google, actually, I think it's right there, Microsoft.com learn, because I was presenting that the other day. You see Python for beginners right here. So if you can start from this one here, Python for beginners, and we give it really starts from the bottom, from the very beginning of Python, and goes into the language structures, the Boolean logic, and variables, and calculations, and lists. You're gonna go through the whole shebang. And this is a learning path from Microsoft. Python is a third-party. Is an open source third-party environment Microsoft adopted and supports. It was created by this guy up down in Europe like 30 years ago and became really popular about, I would say, about 10 years ago. So there are multiple other sources you can learn Python, all right, Badar? So that's my recommendation for you. Some comments there. Defash, Armando, I've mailed about involvement. Kindly tell me how to proceed further. All right, I'll check my social media later. Okay, back in here. Where are we at? We just downloaded the Excel file, and the Excel file is available here on my folder, right? It's right here. It's already there. Perfect. What is next? So this is the Excel file. This is how the file looks like. Again, as a data scientist, as someone that's going to work on this data, you are supposed to come in here and start looking into this and see things that you need to fix on the data. You know, the data came from the data engineer for me with all the sources already kind of combined. But when it gets into machine learning, that's our area of expertise, since you're into the machine learning learning path here. We are supposed to look into this data, see what else needs to be done with this data to support machine learning training. And the rest of these steps are about that. Yeah, so one of the things that when we get data from data engineers is this: we may have missing data. We may want to have subject matter experts to look into the data with us. And this case is going to be the instructions in the learning path. And perhaps even add more data to combine with the data that were given to us. It happens a lot when we are to work on a particular subject. For instance, if I'm doing with supply chain and I'm looking to get products, right, or goodies from one place to another, and I notice that there is a weather forming, I can use this one here to, we're gonna have bad weather on that particular route. So we don't want our truck to get stuck on bad weather. The next data set that I need is the roads, right? The road maps that are around my preferred track and which one would be better on that particular kind of a weather situation. So you always combine multiple data from multiple sources, what they say in the previous step. In this step here, we're gonna bring into our environment the libraries we need. And what's the thing about the libraries? I'm gonna tell you in a second. This video here is the one I told you that she will give you some instructions about how to set up those three guys, right? The Visual Studio Code, the Python, the Anaconda. She goes pretty quick for like 4 minutes. Of course, it's recorded, right? So it goes pretty quick. It will take longer on your computer if it's not already there. So you got the links in here and the Excel file there you should download or have already downloaded that one. And some commands to get the libraries installed. So again, Conda is for the calculation of the models in the back end. You're going to need that. You should do it. Notice that here we're talking about pandas, NumPy, Jupyter, Seaborn, scikit-learn, and Py.plus. What are these guys? These are the libraries. Let me get bigger here just quick. These guys here are the libraries, are the packages that were mentioned before. And the whole point is this. In the slide deck, let me get the slide deck back here just quick. Here in the slide deck, I got this cheat sheet here with these models, right? And if you want to do this model may be a good suit. If you want to do this, these models here can be a good suit. So these models, where are they? I need these models, right? These models, they are packed together into these libraries. So like the scikit-learn is one library with a bunch of these models. Pandas is another library with a bunch of these models. These libraries, they contain these statistical models you may want to use to calculate your label, right? To make your prediction. So what we're doing here in this step is exactly that, is getting the conda environment with these libraries, and the conda environment is based on, works on top of Python. So in this example here, they installed Python 3.8. Let me get this one bigger again. They installed Python 3.8, as you can see over here, right? The Python 3.8. So they installed Python 3.8, and when you install your on Python, you may install 3.9. That's 3.10 is the latest one. You just want to make sure that you match the version, right? Be careful, watch out for these pitfalls. So you get your conda environment installed, right? This is creating an environment there, a REST API in the back end to support the calls. And here you get it started. You make the environment running for you. Down here, and I'm not doing any of this because I have already done. If I was to do this one here, like they mentioned over here, for conda in particular, you are to click on the start button that you guys can't see because my start button is on the screen there. And you find that Anaconda prompt there. Anaconda, what is it? Anaconda prompt. I just clicked here on the other monitor, and I'm going to bring it over here. So this is what they're talking about, right? In the Anaconda prompt, there we go, Anaconda prompt. You're going to run this command here, conda, and off it goes, right? And it's going to make it, it's not going to run because I didn't type the whole command, but that's the idea of what they're talking about. So conda for all of those. And when it gets to pip, you can do the, what is pip, by the way, in case you're not familiar with? Pip is the Python installer, package installer. Libraries, they have a nickname. They can also be called packages. And in case in the Python environment, in the Python context, there are multiple ways you can install these packages. One of them is using this pip command line. And you can do that from Visual Studio, for instance, from Visual Studio Code. So here in Visual Studio Code, I have the option to open a terminal over here and start a new terminal. Another way to do that is to use the keyboard, the control and the tick key. And down here, I get my terminal right there. Let me zoom in here so you can see. See, I got, oops, where's my mouse? There's my mouse. Let's zoom in here again. Yeah, so here, you see on the terminal, I have my command prompt, and here in the command prompt is where I could run those pip commands. So like I can come in here. Where is my instructions again? As you can see, there is this copy icon here. I can click on this guy. You can click on this guy and paste it wherever you need it to be pasted at. In our case here in the command prompt. So I can paste it over there, and it can download. If I hit enter here, it will download whatever library we're talking about here, right? Now, these libraries, installing these libraries are important because you don't want to program things from scratch. That's the whole point. Like we do have an Excel spreadsheet to work with. I don't want to write code to open the spreadsheet and understand all the minutiae inside the spreadsheet file. I just want to get that data into memory. So someone else has already created a library or a package in this case with enough code to go to a spreadsheet, open the file, and make the data available for me. So that's the beauty of a language with multiple libraries, right? You get things done faster because for the common things, someone else has already created a library for you. Like for cell phones, we say there is always an app for anything, right? For computing code, there is always an app for the things. So look for not the app, the library. There's always a library or a package for the things. So look for the libraries, all right? When everything is said and done and installed, let me see this picture over here. Yeah, when everything is said and done and installed, you're going to look into your environment in here, and you're going to create a Jupyter notebook. So there is this command palette in Visual Studio Code that you access by pressing F1. And that's one of the things that's interesting about Visual Studio Code is that, they kind of renew. Oops, it got all blank. Go back. There we go. They reprogrammed some of the keys that we're used to use, right? F1 used to be for help, right? Now it's commands in Visual Studio Code. It's not for help anymore. And if you see over here, I have a list of commands that are supported in my installation of Visual Studio Code because I have a lot of extensions installed in here. And from here, I can tell Visual Studio Code what to do. So I'm going to go ahead and press that F1 again. And I'm going to say here, Jupyter. And notice that as I type Jupyter, it filters out the commands for what is available on the Jupyter context, because I have already installed the extensions. That's the thing about the extensions. So what I want to do is create a new Jupyter notebook. So I could go ahead and just, I can go ahead and just do it from here, Jupyter, and create a Jupyter notebook from here. So it goes ahead and create one here for me, and I can go and save this Jupyter notebook on my Reactor folder. Just make sure it is not going to go away. So there we go. My Jupyter notebook is right here on my folder, and here is my cell where I'm going to type either comments, right, markdown code, content, or my code. So there in the learning path, they're like, okay, you are in Visual Studio Code, you got your Jupyter notebook ready. Make sure that you are connected to a Python runtime environment. So let's go back to my notebook in here, to my Visual Studio Code in here. And here on the corner, on the right corner, I don't have anything selected yet. See, I have to select the Python infrastructure that will run my code. So I'm going to go in there, I'm going to select my kernel. And I have three options in here, right? I have some regular Python installations, and I have the Conda installation. This is my env here, and my environment here is the Conda installation that was instructed for you to create on the previous steps. So what I'm going to do is I'm going to choose this down one here first for this session, just for this example here. I'll switch back to Conda later. So now when I run a Python code, it will run under this particular environment context. And the next thing they ask you to do is, okay, let's see if all the libraries you installed before, if they are available for you. There is no machine learning tasks in here, right? It's just to make the libraries available to our code, to the running context we are working on. So this is bringing pandas and giving it a nickname called PD. This is bringing NumPy and giving it nickname NP, and so far, so on. So I'm going to copy this cell like you're supposed to do on your environment, paste it in here, and I'm going to cross my fingers that this thing is, all the libraries are available there for me because I have already installed them. So hopefully they are there. Let's see. And as you see down here, I got the green check mark. And it took the environment 1 second, 1.8 seconds to go over the environment, over my Python environment, and find out the libraries are there. So if I got this green mark, I did all the installation of the prerequisites. Everything seems to be good to go for me here. I can move on, which means I can come here and add an extra cell for my next exercise, for my next code. And the next exercise here is like, okay, let's bring that Excel data and see what data is available there for us, because we're going to work on massaging that data all along throughout the exercise in here. So for those of you that are not familiar with Python, launch data is a variable that's being created right there as we write it, right? So I'm going to bring that data from the file. I want to get that data into memory. And in order to reference that data that will land in memory, I need a variable to reference that data. So we're going to get that variable there. And we're going to make a call to PD. Again, who is PD again? Let's take a look at here. PD is pandas. It's the library for pandas. Very cool. So there is a method in pandas, it seems, to read an Excel file, and this is the Excel file name I have just downloaded. So let's go have fun with that. PD dot, what's the name again? Read Excel. Read. Look, notice that the library can do a lot of file types. CSV, Excel, Feather, HTML. It can bring data from a lot of standards there. So let's go ahead and choose Excel, which is there on the list. Here, Excel. Always use this thing called IntelliSense. It helps you out and avoids typos, so you don't get stuck on mistyping something, right? So I'm going to use this guy here. Every time we call one of these tools or these libraries, these are called methods, and after the method is always a parenthesis, because the method needs may or may not need extra information or parameters to work on. In this case, it will need, right? You need an Excel. You want to read an Excel file. What's the Excel file name? So I have to enter it in here. The good thing about working on Visual Studio Code in here is I can get that file name right here, right? I don't have to type this whole thing. I can drag. When it gets here to the code, it tells me there that if I hold the Shift key when I release my mouse button, it will put the file name there for me. So let's try that again. I'm gonna click here. Oops, sorry. Back in here, my folder. Yeah. Let's drag this guy here. Press the Shift key. Place it right there in between the quotes. And there we go. I got the file name over there. So this will bring the data into memory. I can't see the data yet. Let me take a look at the data that I just brought in. So the next code in here is exactly that. Show me the description, the header of that file. So launch data head. Launch data dot head. There we go. So this is the other method we call. Armando, they gave this to me. So I understand you just explained. So they gave this to us. Is there a learning path? But where did this come from? Well, again, if you search around for documentation of these things, like if you do pandas, read Excel, it will more likely give you the documentation page about that particular method. If you do pandas head, which is the method we just called the second line in there, it will give you the data frame head. You see the description of the structure of the data frame, the head. So if you click in there on this link, you will get to learn more details on that one. On the learning path, they don't they don't digress like I'm doing here right now, right? They go straight to the point. Use this, you're gonna see the result. But if you want to go deeper on those things, that's how you do it, right? You just Google for the documentation or Bing for the documentation of these things. Back in here, my instructions are here, I think. Yeah, so let's go ahead and run this code. Hopefully it will run, no problem. So there we are. We have here the heads, the description of the data sets that I just brought in. And when you bring data like this into memory, in generical terms, they say you're bringing a data frame. An Excel data structure is more complex than a regular data frame would be. A regular data frame would be just one spreadsheet with the columns in there and the data there. The Excel file can have multiple data frames. In this case, our one does. So there are some minutiae on this one here that are going to save you from that right now. But the point is, the data, we were able to read the file, put in memory, and start looking into the file, the content of the file. So zoom in here, you see some data about the temperature on a particular time frame that was measured. Notice that the temperature at launch time of a particular launch, because this is data about launches that were there before in Cape Canaveral. Some of them don't have data available, not available. See, NaN is not available. There is no data. So for machine learning, this is a bad thing. How can I make a prediction when I don't have data to make the prediction? So I have to figure out what to do when there is no data available for a particular data point, right, of my data frame. When a feature is missing data on some rows or tuples. In any case, I was able to read my data fine. That's great. Let's move on here. Begin exploring your data. So like this is another method you can call launch data columns. So just to avoid typos, I'm gonna copy it from here, add a new code cell, place that one in there. Let me see here. See, Control Alt Enter is the shortcut key to execute a cell. And there we go, right? We have in here, these are the columns that are available on that data set. So got name, date, time on the East Coast, so EST time, location, and off we go. So with that, I think you are ready to keep going on this learning path in here and keep doing the rest of the exercise and analyze and clean the data and manipulating the data. For example, in this topic in here, they're going to request some data about what is in there. So data info is going to give the statistics of the data frame. Let's get that there. Launch data info. So let's get this here. Launch data info. And when I run that, I see the statistics about my data. So what I have in here, bound data, the ranges of the data that are in there. I can start looking into the statistical distribution of my data and start making sense and get acquaintance with the data. In here, let's see. Yeah, so that data info with the parentheses, with the method. So that was a property that I called before. This is the method that I have just called in here. So I have a different result in here with more, other aspects of the data. And that's what, as a data scientist, is what you do. You gotta have a quantity of the data and understand your data and remove things and change things you have to change. Notice the data type of the data there, right? You got some numbers, which is great for statistical models because they want to work with numbers. But you do have some other data types that are not numbers, especially these objects in here. So when you see these objects, they usually refer to strings or some complex data types that you have to work on them and clean them up. In this case here, on this next command here, this last set of command here, they will start looking into the data when there is missing data. Like remember that launch we have seen that in the data sets. If there is no data there, if you look into launch feature in the data frame, if there is no data there, this method here called fill NA, remember NaN, none, means no data there. If there is no data there, it means more likely that there was no launch. So make that an N instead of not having data, because now I know what happened. There was no launch. Crew or no, was there people in the capsule in the head of the rocket, or was there no people there? So again, if there is no data about that, so we assume it was there were no people there. You see what it's doing? It's not that the data is dirty or not well formatted. It's lacking information that's important for statistical models. Statistical models, they don't like missing data. So one of the things we do is exactly that. We fill up the data that it's important to have, and it's not there. In this case, we're looking just on labels, so it's just putting a default value in there. When it's numbers, you can use like averages or standard deviations to get a particular range of number to get on a missing data, as long as it doesn't bias or create some deviation on your calculation. So let's get that here in a cell. Where is my cell? My cell ends over here. What's my result? Okay, let's add a cell over here then. I think they didn't want to show for some reason. Gonna add a cell over here. Let's get this guy here, get it to run. And we have just done some data cleansing right now, right? We fill up some data that was missing. Remember, there was a non-available data here on this column. Now we have the N unlaunched. We replaced, so now we have some information in there. And our almost up time in here, we have just 5 minutes to wrap this up. So I'm not going to have time to go around all the steps in here. But once you have an environment going, you see it's pretty straightforward. And what you really need to do in here is grasp the intention of what each one of these steps are all about. The one we have just done is about filling the gaps, right? Putting data where it came missing from the sources. And when you write this as a script, if you have a new data set, a new collection of data with the same structure, but updated, let's say that was from 2018, let's say you get one from 2020 and want to mix them together, you can use the same script. It's already developed there, already programmed, and it's going to run just by executing it, right? Development first time is the time-consuming task. Once it's developed, you usually just execute it again. And here we go for the knowledge check once again. When you finish a module, so why do we need to clean data? So others can read the data more easily. Computers get confused by inconsistent data to create better visualizations with the data. I guess it's the second one. I didn't read the text, so I guess it's this one. Which of the following is not a library we are using? PyTorch, Pandas. I think PyTorch is not one that we brought in. Pandas we brought in, Scikit we brought in, NumPy we brought in. So let's check. Yeah, I got that right. Just collect 400 points. All right, it's recorded, so you can go ahead and do that yourself, and you have 400 points guaranteed. Let's go to the next task. Oh, come on. There we go. Keeping up on the machine learning model. Now we're going to do the next. We're going to stop it here, but you see, we move to the next module where you're going to do the rest of the tasks that we have discussed earlier. Further data cleansing. So what are we going to do in here? We're going to look into names, dates, and see if there are missing information in there. If they are, remove them. Look into the columns that are in there, and off we go, right? So I hope that gave you a good kickstart on the process, how the process of having machine learning work for you, how it develops on the life cycle, all the things about the models you can come to choose, and also show you how easy it is to start learning these things on your own time by following these steps. And, I myself, I like to run through these learning paths before I sign up to a class where there is a trainer there, because when I go to the class, I already know some stuff, so I can, make better questions. I got my feet wet already. I hope you have enjoyed this session. I hope you have learned something new. I don't think there are any questions there on the chat window. Fazir, I give the microphone back to you, and wish a good night, good morning, good evening for everybody out there.
Thank you so much, Armando. It's a very nice session. Thank you so much. And thanks everyone else for joining as well. I just to wrap it up, I just shared the AKA link for the survey link, for the Reactor survey link. We'd really be more than happy if you were able to give us some time and try to fill this survey up to tell us how did this event go. Please use the code 15884. And other than that, Thanks again and have a good one.